Alright, so this video is about 4.3, increasing and decreasing functions of the first derivative test. So, have fun without me, but be ready to take some notes, okay? Some of this we've actually explored quite a bit, so it won't be completely new. I mean, I've actually already done a lot of it with you. It's just a matter of putting it all together and formally doing it, okay? So, in general, it says a function is increasing over an interval if the derivative is. So a function is increasing if its slope or the derivative is positive. And a function is decreasing over an interval if the derivative is negative. So when it asks me to do something like this, determine where the graph rises and falls, when it's increasing and decreasing, I really need to just determine my critical points, and from there do a sign chart, kind of like how we did with the extrema the other day. So I want to find f prime. So the derivative is 3x squared minus 3x, because you bring the 2, cancel out with the 2, subtract from the power. Okay, and critical points are when the derivative equals 0. So like I said, anytime I can factor something out, I'm going to. And I see that my critical points are 0 and 1. So what I do is I sign chart, and the only thing you label is the critical points and what f prime is going to be. So you pick any number less than 0, say negative 1. When I plug it in, I get negative here, and I get negative there. Negative times negative is positive. Between 0 and 1, 1/2. If I plug in 1/2 here, that's positive. 1/2 there, that's negative. So that is negative. And greater than 1 is 2, so positive and positive. Now this is a polynomial, so it should follow the rules like that, especially when the multiplicities are 1. And you know it's a positive cubic function, so in general it starts on here and ends up there. So it should start out increasing, decreasing, and then increasing. Now it doesn't have to decrease at all, but this one does. So when it says when is the function, so if I were to answer, when is the function increasing? F is increasing on the intervals negative infinity to 0 and from 1 to infinity. And f is decreasing on the interval 0 to 1. And we don't include those because at those moments you are stopped. Okay? On this one it says, and that graph does not go with this. It's from, I forgot to delete that. Okay. The first derivative test. So the first derivative test is basically take what we just did, find the sign chart, use a sign chart, create a sign chart, I know you get there eventually, and determine if you have maxes and mins. Well, looking at this graph, I know that this function, this cubic function, has a maximum at 0 and a minimum when x equals 1. And so if I wanted to actually find the max and the min, I could plug them into the original function. Now, this is on open intervals. This is not on a closed interval. If it's a closed interval, I would have endpoints, and I would consider those as possible maxes and mins as well. But if you're purely going on just the function on all real numbers or its domain, then the sign chart is where it's at. So, first derivative test. I need to find f prime. So f prime, the derivative of 1/2 x is 1/2, and the derivative of negative sign is negative cosine. So I want to know when 1/2 minus cosine equals 0, which is basically when 1/2 equals cosine. And we're only on the open interval from 0 to 2 pi. So when I think about cosine is the x, and so the x is 1/2 right here, and that's pi over 3. And right here, where it is, there's 5/3. So I've got two critical points. X equals pi over 3 and 5 pi over 3. So I'm going to do a sign chart, again, not the graph. Here's pi over 3 with an endpoint of 0, and 5 pi over 3 with an endpoint of 2 pi. Now I put it as parentheses because those are not part of the domain. So f prime. Between, there's a couple different ways I could look at this. I could actually sketch the graph, or I could just think about it. Like, between 0 and pi over 3 is pi over 4. So cosine of pi over 4 is square root of 2 over 2. So that is going to be, let's see, is that going to be negative? I think so. Let me go ahead and sketch that right quick. So here's cosine. And negative cosine does this. And then plus 1/2. So that shifts it up. So if this is -1 and that's 1, then, and that's 2, then that puts me right here. And my peak is there. And then I come down to here. Yeah, I think at until pi over 3, let's see, that would be pi over 2, yeah. I think that is going to be negative. But yeah, I don't know why I'm waffling on that. I just want to be sure. So cosine, that's square root of 2 over 2. Yeah, 1 minus square root of 2 is negative. So that's negative. From pi over 3 to 5 pi over 3, we could pick pi over 2. Cosine of pi over 2 is 0, so that is positive. And if after 5 pi over 3, I think we're down here again, so that would be like, we could do 11 pi over 6 or 7 pi over 4. Either way, you'll get another one of these. Well, actually, yeah, because it'll be positive. And so it'll be negative again. And so that kind of mimics the graph. The original one. I am decreasing because my derivative is negative, and then my derivative is positive, and then my derivative is negative. So f is decreasing from 0 to pi over 3, from pi over 3 to 5 pi over 3, f is increasing, and then decreasing from pi over 3 to 2 pi. So if I were to determine where my extrema are, I would say that I have a minimum. I would say f has a min at x equals pi over 3, because f prime changes from negative to positive. Okay, at pi over 3. Now if I actually wanted to find the minimum value, I'd have to plug that in. 1/2 times pi over 3 minus sine of pi over 3. So that's pi over 6 minus, and then sine of pi over 3, sine is square root of 3 over 2, which is oogly, but that is the minimum value. So the min coordinate point would be pi over 3, comma, pi over 6 minus square root of 3 over 2. Or you could do a common denominator and say pi minus 3 squared, so 3 over 6. Okay, as far as the max, I would say f has a max at x equals 5 pi over 3. Because f prime changes. And you have to do that because on the AP exam, they're almost always going to ask you for justification. And there's going to be applications, and you're going to say, okay, I know there's a max because this happens. F prime changes from this to this. And it seems simple, but that is what they want, okay? F prime changes from positive to negative at x equals 5 pi over 3. And equals 0, I mean, that's kind of important, that we're finding where it equals 0. Because if it was undefined, but then changed to positive negative, that would not be a max or min. Okay, so using the first derivative test, I want to find the relative extrema of this function. So I need to find f prime. F of x equals x squared minus 4 all to the 2/3. So the derivative is going to employ the chain rule. So 2/3 all of this to the negative 1/3 times the derivative of the interior, which is 2x. So in general, I've got 4x over 3 times the cubed root of x squared minus 4. Now my critical points are when the derivative is 0 or undefined. Don't forget that. So my numerator is 0 when x equals 0. Okay? My denominator is 0 when basically x squared minus 4 equals 0. And so that's when x equals plus and minus 2. Okay? If you were to actually set it equal to 0, you would just end up getting rid of all that. You would divide by 3, you would cube both sides, and then you would subtract 4 and take the square root. So I've got 3 critical points. -2, 0, and positive 2. If I don't have any boundaries, then I just keep on going. The only thing you should ever label, even if 0 was not here, is the critical points, okay? So I need to plug them into my derivative. Negative 3. So that's a negative. A negative 3 squared is 9, minus 4 is positive, so that is going to be negative, which means f is decreasing. Negative 1, so that's negative. That's positive. No, that's negative. Negative 1 squared is 1, minus 4 is negative, and the cubed root of a negative is negative. So it's a negative divided by negative, which is positive. 1 is positive over negative, again, so negative. And 3, positive, positive. So f is decreasing, increasing, decreasing, and increasing. Now, it's important that we know that f is defined in these numbers. So if I plug in negative 2, positive 2, and 0, I get real numbers. I don't get something that's undefined, an expression that's undefined. So f has values at each of these, and in fact, f has a min at both negative 2 and positive 2. So f has a min of, and let's actually plug them in. F of negative 2 is the same thing as f of positive 2 because it's x squared. And so it's 4 minus 4, which is 0, to the 2/3, which is 0. A min of 0 at x equals plus and minus 2. Because f prime changes from negative to positive at these values. And then f has a max of, if I plug in 0, I get negative 4 to the 2/3. You could say the cubed root of 16 if you wanted to. Or you could just say, yeah, let's just go ahead and do that. The cubed root of negative 16, positive 16. Why did I say that? 4 squared, negative 4 squared. And then the cubed root. At x equals 0, because f prime changes from, I should say f prime equals 0 and changes from positive to negative at x equals 0. And actually, if you look at the graph, it looks something like this. Actually, I don't remember. I know it does something like this, but I don't know how that leaves from that, if it's like that, or if it's another way. I think it's something like that. I'm not sure, though. It could do that. I don't remember. Okay. So, find the relative extrema. In order to find the relative extrema, the first thing I always want to do is find the derivative. So I've got x to the 4th plus 1 over x squared, which I could use the quotient rule on, but I'm smart, so I'm going to think that I should split up the fraction first to make it a whole lot easier. If you're only dividing by one term, it makes it a whole lot easier if you split it up. And so I'm really just finding the derivative of x squared plus x to the negative 2. Okay? So f prime of x equals 2x minus 2x to the negative 3rd, or minus 2 over x cubed. Okay? Now I need to have one fraction, so I can have numerator denominator. So I'm going to multiply by the common denominator, which is x cubed. So 2x to the 4th minus 2 over x cubed. And I want to know when this equals 0 and when it's undefined. So I need to know when 2x to the 4th minus 2 equals 0 and when x cubed equals 0. So that's just 0. This is just when x to the 4th, add 2, divide by 2 is 1. So x equals plus and minus 1. Okay? So I've got 3 critical points. Negative 1, 0, positive 1. So we plug in everything around them into f prime and see what happens. So if I plug in negative 2, so negative 2 to the 4th is positive, so that's a positive because it's larger. But then divided by negative 2 to the 3rd, which is negative, so that is negative. Negative 1/2. So if I plug in negative 1/2, so that is 1/16, so 1/8 minus 2 divided by a negative 1/8. So negative divided by negative is positive. If I plug in 1/2, I get a negative divided by a positive, which is a negative, and if I plug in 2, I get positive over positive. So I know f is decreasing, increasing, decreasing, and increasing. So f has a min of, if I plug in -1 into the original, and +1, they're both being raised to an even power, so they're the same. If I plug in -1, I get 1 plus 1 over 1, so 2, at x equals plus and minus 1, because f prime equals 0 and changes from, let's see, negative to positive at x equals plus and minus 1. And then f has a max of, let's plug in 0, I get, oh, that doesn't even exist. So what happens here is that I have to remember that there's a vertical asymptote here. And so if I plug in 0 in the original, I get 1 over 0, which is undefined, so f does not have a max. Okay? Which is kind of interesting. So it all depends on whether or not, like, you can do this chart, but as long as the function is undefined at that number, it doesn't matter. You know, this just tells you what you're doing, and I know that I'm increasing to an asymptote, and then I'm decreasing away from that asymptote. Okay. So, and you can also graph it to make sure, but I'd rather you do this first, this analysis. Use analytic methods to find the local extreme and the intervals of increasing and decreasing. So, there's f, and I want to find f prime. So the derivative of 4 is 0, and the derivative of this is a negative 1/2 x plus 2 to the negative 1/2 times the derivative of the interior, which is 1, which is really just a negative 1 over 2 square roots of x plus 2. So when I think about the critical points, that's when f prime is 0 undefined, and this is the denominator is 0 when x equals negative 2. Okay? So if I do a sign chart, I'm covering the graph because I don't want you to look at it yet, although you might have already seen it. So my only critical point is negative 2. Okay? So if I plug in anything below negative 2, like negative 3, I get the square root of a negative number which does not exist. And in fact, neither does the original expression. And then right here, when I plug in, like, say, 0, I get a negative divided by a positive that is negative, okay? So what that tells me is that the function, because the function itself does not exist past negative 2, the function is only decreasing on its domain, which is from negative 2 to infinity. So it makes sense that the maximum would have to be at the endpoint negative 2. So if I want to figure that out, I would say, or find out what the maximum is, I would say f of negative 2 is, so I get 4 minus the square root of 0, which is just 4. And so I know that I have a max at x equals max of 4 at x equals negative 2, because f prime equals 0 at, well, f prime doesn't equal 0, f prime is undefined, because you don't have derivatives at endpoints, at x equals negative 2, and let's see, let's do the function doesn't exist for negative infinity to negative 2, and f prime is negative for negative 2 to infinity. What you're telling me is that your graph, your function, doesn't exist past negative 2, and then after negative 2 it's decreasing forever because the derivative is always negative. So if you're decreasing forever from a certain point, then that has to be your maximum. Okay. So in this one we can kind of see what the graph is doing, but let's see, do I want to do that? Nah, I'll leave that to you. Okay, so here is your homework for 4.3. So maybe just pause the video and write that down, and that is what I expect you to do. Okay, bye guys.